Hello, my name is Achim Dobermann, and I'm happy to meet you. And on the other hand is Lauren. Lauren, will you say something?
Hi, I'm Lauren Barreto. I'm the head of partnerships for the Sustainable Development Solutions Network. We are looking forward to those of you who are joining us with our Meet Our Leaders series. Today, our leader is Achim, who just introduced himself. He's a member of our Leadership Council. He's co-chair of our thematic network on sustainable agriculture and food systems. And he's also the lead faculty of the SDG Academy MOOC, Feeding a Hungry Planet.
Good. How do we do this?
I don't know if you want to say anything else briefly. I mean, so it's going to be an interview. I have some questions that I'm going to ask you, and there will be other questions coming in, hopefully online from our audience. Send us a comment or a chat to ask a question to Achim directly. But I don't know if you just want to start with a brief introduction of you, yourself, your work. Achim is also CEO of Rothamsted Research in Harpenden in the UK. I don't know if you also want to talk about some of the exciting things that Rothamsted is doing by way of introduction.
Good. Yeah, I'll give a bit of a background, but largely to give people some time to send us some questions they want to ask. So I actually grew up in what was at that time East Germany, or the German Democratic Republic. So I spent the first 30 years of my life there, all my childhood and also education, and grew up in a farming family. And obviously that then led me to gain an interest in agriculture as such, and then somewhat later agricultural research. And I didn't really know anything about research when I was younger, and nobody in our family had a scientific background or anything like that, so that was a new thing for me. So I went through a progression of steps to get there, but ended up studying tropical agriculture at the University of Leipzig, and that was very interesting because it was a program that took 5 years, and you had to take 50 courses. You had no choice, you had to take them all 50. And that was just about anything that had to do with agriculture, so from the soils to the plants to the animals to accounting and engineering and economics. And I found that to be very useful because it allowed me to get a lot of information about all of these things, and that's essentially also what agriculture is about. It's I think for me, one of the most exciting professions, because you need to deal with all of these things. And it doesn't matter whether you're a farmer or a scientist, it's a complexity of different pieces of knowledge that you need to know about, and then also make decisions in your daily life. So I find that particularly interesting about this type of profession. I got interested myself as a student, and specifically in soils, mainly because I think that was the most interesting lecture that I heard, and there were lots of questions open. And then I got interested in rice because it made me wonder why it is that some crops like rice actually like to grow and happily grow in a soil that is completely submerged with water, whereas most others die. So you start wondering, as a young man or young person, what's going on in that soil that's so different? And so I got interested in rice, worked in Russia for my PhD in a farmer's field to investigate everything that I could find out what was going on in that field. And then later moved to the International Rice Research Institute in the Philippines to work a lot on soils and nutrients and the long-term sustainability of intensive rice systems in Asia. It was an exciting time in the 1990s. There was a lot of new initiatives. And so I think it was a forming period for myself to work on problems that really had relevance for moving the development of the lower and middle income countries forward. So I then later spent some time in the US to work on more large scale in precision farming issues in the American Midwest. Came back to the International Rice Research Institute, and a few years ago joined Rothamsted. So the last 10 years of my career have largely been dedicated to leading research or research institutions, and in that role obviously you have to deal with many different scientific issues besides the managerial type of things. And here at Rothamsted, I would say we are one of the few institutes left that still are able to do quite interdisciplinary science from, if you wish, from the gene to the landscape scale. So we have lots of different disciplines, and we increasingly need to now also find new ways of making use of that type of science expertise and different scientific approaches to address more complex problems in agriculture, because individual sort of single silver bullet solutions are going to be quite rare. So I'll leave that introduction at this, and hopefully we can come back to some of these things.
That's great. I think actually, going off of the last point you made, it'd be interesting to hear what you think are some of the key challenges that are currently facing agriculture, and what you think might be some interdisciplinary approaches to finding solutions, whether that's interdisciplinary approaches on research, implementation, sort of the whole gamut of that.
I mean, there's lots of these big challenges, but obviously the biggest one, and that will never go away, is food security, in the sense that as long as we have a rising population worldwide, and in some parts of the world even much faster than in others, the demand for food will rise too. And with economic growth, it'll rise even further for some food categories, meat in particular. That's the number one challenge, and it's not one that only has an agricultural solution. It's largely also a solution that needs to be built around levels of population growth control that need to be achieved in every country on Earth, because otherwise you really feel at some point find it difficult to produce enough food on a sustainable basis. So that's the number one, and that itself, I think, has many intervention options. And they differ from country to country. So we have, in my view, still sufficient gaps. If we fill those out through better technologies, knowledge, better infrastructure, extension systems for farming, better marketing systems, that if we do all these different steps together, we fill or close existing gaps in productivity and efficiency, I believe we should be able to produce enough feed for the next 20 to 30 or 40 years, and so a world population of up to about 9 to 10 billion. I'm quite confident about that. But anything above that becomes a much more challenging task. And then, of course, there are other big challenges that we work against. One is the nutrition question. So it's not just undernutrition anymore. It's largely also the better nutrition, healthier diets for anyone, including here in the rich countries. So we have new problems of that kind to solve. So we need, I think, new agricultural models also that help us to increase the nutritional value of our farming systems. And then make food that is produced in that way, and hopefully also healthier, more locally available. So I think that's a big challenge, how to do this in a world where a lot of it is based on cutthroat competition and low prices and things being moved around based on that all across the world. I don't think that's necessarily a very sustainable model, but we also cannot ignore the commercial realities of a farmer who needs to survive. And maybe a third one is, of course, that we are concerned about anything related to climate change and the need to adapt to it. I think we have a lot of opportunities there from a sort of scientific point of view too. So it's not just crop genetic improvement or animal genetic improvement for adaptation, but also the improvement of whole cropping or farming systems to be more resilient, and as a result of that also less variable in their productivity. So that's a big challenge, but it requires that people from many different disciplines, but also public and private sector, work a bit more closely together in the future. And these are just three examples of some of the big challenges that I see.
And if we could go back to the one on nutrition and sort of the whole food chain and food system, could you maybe talk a little bit more concretely about some interesting project or innovative program or initiative that's trying to focus interdisciplinary work on that. I know that you need big agriculture, farmers, healthcare providers, distributors, grocery stores, individual behavioral change. Maybe that's a place that you have a illustrative example that you could share.
And we don't work that much on that end, so on the consumer end or retail end from where we are in our institute, but that's obviously extremely important to a lot of this behavior change in the sense of people needing to make the right kind of choices in terms of what they buy and what they eat and how much they eat of it. So that's an educational issue as much as it is also an issue of some form of better regulation, but also more serious attempts by the food industry, those who process and market the food, to really essentially remove things that are bad for our health in favor of more things that are good for our health. So, and give people the right kind of choices. But there are also more technological solutions that I think can play a significant role. So here at Rothamsted, we are involved in one particular product, a potential product that could make a sustainable source of fish oil in plants. So you have a situation, for example, that aquaculture, so to produce fish, which is a good part of a normal human diet, is expanding rapidly worldwide. It's already bypassed wild fisheries as the major source of fish product in the world. So it's growing fast, but to grow fish in aquaculture, you also need feed ingredients such as fish oil, which at present to a large extent are being harvested from wild fish. So it doesn't make a lot of sense if you think about it to harvest wild fish, to get fish oil out of them and feed it back to farm-raised fish. So we have a genetic engineering solution for this that allows us to grow an oilseed crop, in this case Camelina sativa or false flax, that actually has a changed oilseed composition that makes that kind of fish oil. So and all we would need is a few 100,000 hectares in the world to grow with this crop, and it could provide a sustainable source, a land-grown source of highly nutritious fish oil for the aquaculture sector, and therefore contribute to improved nutrition of humans. So these are the types of solutions that, even though in this case it's a biotechnology solution, actually trigger quite a chain of things and actually address a food systems issue. And there are quite a few of other types of opportunities of that kind.
Yeah, the Camelina research is really exciting. I think it's partially interesting because it identifies sort of a global trend that's been happening, the rise of population and the rise of aquaculture, and the need to make sure that people are getting proteins, but it ended up not necessarily being done in the most sustainable way. So, this research specifically is coming up with the solution to try to improve the sustainability. I don't know if there's sort of another global trend that you've seen across your career that maybe had some unforeseen consequences, where research has provided an opportunity to come up with a solution. I don't know, maybe climate change or, some of the other issues that you're familiar with.
Well, I mean, I'll cite one that interests me a lot because I've spent quite a few years working on this issue. So, and that is over the last 50 years, we have in agriculture become very much dependent on the use of fertilizers, in the sense that on a global scale, there's usually been a linear correlation between the increase in fertilizer use and the increase in crop productivity. So the challenge now is to, in many ways, break that relationship. So we still need to increase productivity, but not at the cost of the same rate of increase of fertilizer use than we've had in the past, because that would create too many environmental problems. So we already have quite an excess of what we call reactive nitrogen forms, so things that are biologically or physically active in the biocycles, but also atmosphere. So that results from the human-induced capture of nitrogen from the air and turning it into fertilizer, and from there leaking from the fields back into the water or into the air. So there's cycling of these things going on. So the challenge is now to achieve a new kind of agriculture that has a much higher use efficiency of nitrogen fertilizer, for example. And that requires quite a range of interventions. But we also have worked for many years, and many others do this, on more precision farming type of approaches that essentially aim to increase a higher conversion of nitrogen in the field into the plant, to reduce losses directly, achieve higher yields with the same amount of fertilizer or even less. So it's not just a fertilizer management question anymore. It also in the future can benefit from crop genetic improvement and other types of interventions, such as big data applications for agriculture, new sensors. So lots of technology that can contribute to address this particular problem. And I think it's one example for how agriculture in general needs to change. It needs to be a lot more precise, a lot more tailored to specific conditions, a lot more sophisticated. So, and that's actually also quite exciting. So farming increasingly is becoming a profession that is very much based on also the use of modern technology. And that's not just in the rich countries. I think increasingly also will be the case in developing countries, even in smallholder agriculture.
You keyed me up perfectly for a segue into one of our questions from one of our listeners. So you were talking about crop genetic improvement. We had a question on, let me get it exactly. Given the recent advances in biotech, are gene banks still a good and worthwhile investment, given that they can be quite expensive to set up and maintain?
I think they are absolutely essential. I'm a big fan of gene banks. I don't consider them to be like dead things who just store seed. Gene banks are actually very exciting things because they contain a treasure trove of genetic material, which at present we have only scratched the surface in terms of really using. So I don't know what the numbers are right now, but a few years ago when I was still working on rice, we always concluded that only a fraction of the genetic accessions that we had at IRRI in the world's largest gene bank for rice. There were over 110,000 different accessions of rice. Only a small percentage of that has ever been actually used in active breeding programs for improving rice. And I always got excited because every growing season at IRRI, they take about 3,000 of these accessions from the gene bank and grow them in the field. So you have, let's say, 3,000 plots of different rice varieties, and some of them maybe haven't been grown for the last 25 years. So you see that plot and you see all these different types of rices, and you get the idea of what amazing genetic diversity there is. And I do not believe that any plant biotechnologies can mimic this at this stage or any time in the near future. So for me, these gene banks need to be utilized much more. We need to add more data and information to every one of these accessions. They're already widely available to anyone, freely even. And the cost of running a gene bank, well, in the big scheme of things in the world, that's peanuts. So to run the world's biggest gene bank for rice at IRRI, I don't know exactly what the numbers will be, but let's say it's probably not much more than $1.5 to $2 million a year. So put that into the context of how much you spend on a fighter jet in a country or whatever else it is, and what the benefit of that one is versus a gene bank that can have long-lasting, massive impact on the improvement of a crop and therefore to the benefit of billions of people, not just a few million. So no, absolutely essential. I don't think we can achieve all of these things with biotechnology approaches only. What I will also say is, based on experience in the last few years, if you would have asked scientists maybe 15 years ago how one should go about improving a certain trait in a crop, drought tolerance or whatever, many would have thought that, well, it has to be done through some genetic modification approach, or transgenic approaches. I think with the advances in genomics and molecular breeding approaches, a lot of these things can now be done using the native or the existing diversity of genetic resources, harvesting genes from the existing species and integrating them or putting them more specifically into varieties. So it's not a pure GM or biotechnology approach anymore for this, even though in the past maybe that would have been required. So we'll see much more of this. And to do this, you need to have these gene banks.
Yeah, I don't know if you want to talk a little bit more in detail on, for example, the work that IRRI did on flood tolerance in rice and the millions of farmers across Asia that has helped based off of genes that were bank.
Going into the details, and I can't claim the credit for it because other people did all that work. Yeah, but essentially it took 30 years to do this. So there were already native varieties known, particularly from eastern India, FR13A in that case, that were submergence tolerant. So even rice likes water. Most rice varieties, if you get them submerged in deep water for more than a few days, they will die. So, but there were traditional varieties in eastern India that can survive that, and if the water recedes, they can continue to grow. The problem is that these were low-yielding, gangly, tall varieties. We couldn't really improve them much. And it took a long time to find the gene responsible for this, because initially the molecular biology methods or genomics information wasn't available. But once it became available in the early 2000s, it went very fast. You could identify the gene, understand its mechanism, and immediately start the breeding program. And within a few years, a new generation of flood-tolerant varieties went out to farmers in Asia and probably have reached now 4 or 5 million farmers already. So it's essentially free crop insurance for farmers built into these varieties. And scientists have now added other things on top of that: drought tolerance, salinity tolerance. So it's become a whole new way of breeding stress-tolerant rice varieties, and the same thing has happened in some other crops already. So it just shows what is possible with some of these new approaches, and I think it's really exciting to see this coming along.
Great, and I'd like to tie this into a question that we got online from Kim Mack. So flood-tolerant rice is one example of sort of a technological solution to a problem. She asks about how the adoption of new technology can sometimes be different for farmers, difficult for farmers. Sometimes they're resistant to new ideas, new technologies, new crop varieties. She specifically asked about fertilizer. So her question is, how can we encourage rural farmers to have faith in investing and using new technology, new methods, new varieties, things like that?
Yeah, that's absolutely right. This is, for me, actually one of the biggest concerns, because, I mean, typically in agriculture, the time it takes to develop something new, a new innovation, a new technology, 10, 15 years. And then what we often see is it takes another 10 to 15 years until it reaches peak adoption. But there are also plenty of things that scientists come up with, or companies for that matter, that actually never make it. So we seem to be doing also in science quite a few things that may or may not be adoptable by a farmer easily. So we need to, I think, to overcome this, really ask ourselves this question: can we find ways to also change the way we do research and innovation to make sure earlier from the beginning that we engage much more with the end users of that innovation, to make also sure that whatever we come up with is actually something that they want and that they can use. So I think there's still too much of this sort of linear model around of the kind of somebody comes up with an idea and then hopes that somebody's going to pick it up and use it. And if you think about it from the farmer's end of the chain, you as a farmer have to make lots of decisions, fertilizers being one out of many decisions, and you have to weigh the risks. If you get it wrong, it may mean that you lose a big amount of economic value in a particular growing season, a crop, And in a lifetime of a farmer, you only have maybe 30 or 40 years to experiment, and you can't afford too many failures because your livelihood depends on that. I think we need to, look at this a bit more realistic from that angle. Also, scientists in particular to go out earlier and actually develop a lot of these innovations, particularly when it comes to improved practices that essentially require a change in the behavior of a farmer or the decision making. They require knowledge. So any of these types of things that are a bit more complicated, or sometimes we say knowledge intensive, I think need to be developed or co-developed much more earlier on and piloted and tested in that way with the end user, in that case the farmer. Other technologies, particularly seed-based technologies in which one can embed a lot of things, are probably a bit easier to deal with because I think every farmer in the world understands that one of the key ingredients for a successful crop is a good quality variety and seed. So if one can embed a few more things into those, it usually ensures much wider uptake. I think we've also had the problem that the extension systems in many countries are still too weak or have become even weaker. And that's actually not necessarily only a problem for developing countries. I would even argue that in some of the highly developed countries, the trend towards privatizing agricultural extension systems has put particularly smaller farmers at a disadvantage. You don't necessarily have equal access to the latest knowledge and technologies anymore. So I think the question of investment in extension and building up skills and knowledge of farmers and also agronomists or others who advise them and serve them is extremely important, and I don't believe that most countries are investing enough in this actually.
So turning a little bit more to the macro level and thinking about countries that have a large percentage of their population employed in agriculture, we have a question about what's the optimum growth rate for an agriculture sector, specifically for developing countries where most people are employed in agriculture.
Wow. That's a tough one, and I'm not an economist, so no matter what I will say, I'm pretty sure that any economist will challenge that. So I'll aim a common sense answer to that. So I mean, obviously, the minimum growth that is needed needs to match what your population grows with as a starting point. Because if you don't do that, then you will fall behind even more. But it also depends on what is the desired level of food self-sufficiency or sovereignty a country should aim for. And that's not an easy question to answer because many countries realistically cannot produce all of the things that they need simply because their soil, climatic, water, other natural resources don't allow that. So you have to factor in a certain level of trade, and then you have the problem that some countries actually are well capable of producing a lot of food in excess. So they're rich in natural resources. Take some of the South American countries like Uruguay or Argentina, who have huge amount of agricultural resources, but a relatively small population and therefore can produce a lot of food. Uruguay produces food for about nearly 30 million people in the world, even though it has only 3.5 million people. So it's very difficult to say what the optimal growth rate is. But I would say for countries, particularly in the developing world, where agriculture is a significant part of employment and the overall economy, I would hope that many of those could aim for growth rates which are more in the order of 3, 4, 5, or even more % per year. That'd be, I think, a reasonable target for me, and particularly if that can largely be achieved through greater efficiency growth, or what we call total factor productivity growth, as opposed to expansion of land or other extensive inputs.
Great. And going off of that as well, if we had growth like that in the agriculture sector, I think it would really help at reducing rural poverty. We have a question about the use of universal basic income in the SDGs, which I'm going to make a little bit broader and a little bit more tied to agriculture. I'm going to say, sort of generally speaking, what do you think the SDG framework or other solutions are for sort of this idea of increasing economic development in rural areas, reducing or eradicating rural poverty, and trying to improve rural livelihoods?
Yeah, I've been involved in the process of developing the Sustainable Development Goals through the SDSN since about late 2012. So, and I would say it's been very interesting as an experience for me. I was not much involved in these things before, and I think the main conclusion that I have is that it's really great to have something that the 193 countries have agreed to. Would I have come up with the same 17 goals and numerous targets? Probably not. It could have been done in a more, hopefully, simpler and integrated manner. But it is the result of a complex global negotiation process and consultation process, and that's great, So, and I have nothing really wrong with any of the goals, So it's mainly a question of now making use of this framework in our daily work. So, obviously, for agriculture, SDG 2 is the most important one on food security, nutrition, sustainable agriculture. But there are elements in at least 7 or 8 or 9 other SDGs targets in those that are directly impacted or indirectly by agriculture. So it's actually, for that reason alone, great to have that framework and actually also see agriculture being recognized a bit more clearly in it again, among many other things that, of course, the world needs to pay attention to. So I really want to hope that organizations of any kind, be it public or private sector, now take this framework, and many have done so already, and basically say, yep, we can do something about this in our own world, in our daily work, in our business.
Great, thanks. So the next question is about the role of urban farming in food security. They're looking for your views or how important urban farming is in this regard, and any interesting technologies you'd like to comment on: terraces, greenhouses, vertical farming systems, etc.
The first thing I need to do is move a little bit because my power supply is running low here, I noticed.
Oh, no.
So hang on to it. And I don't have a power supply source, but yeah. Okay, that should do. I'm back online. Sorry for that. Urban farming. I don't live in a city, so I don't really know what people are doing there. But of course, there's been quite a bit of movements. People trying to grow vegetables on rooftops of buildings. There's interest in vertical farming of various kinds, so in tall buildings with completely controlled conditions. And then, of course, there are home gardens of any kind that have been around for a longer time, or at the peri-urban areas, also some more of the allotment kinds or whatever people want. Yeah. So I think these are all great things to do. They can be, I think, an important part of the local food supply. I think they're also good in a sense that they reconnect people with where food comes from. And so we have this problem that a lot of young people or children growing up in cities and only seeing food in restaurants and supermarkets can't really quite understand anymore what it is actually made of and where it comes from. So I think urban farming activities of any kind can play a significant role of the educational character. I think we need to be realistic in terms of how much food and what kind of food can be produced in these kind of systems. I think it would largely be things for more immediate local consumption, whereas the bulk elements of the food chain, let's say cereals and other types of things of which we consume huge amounts worldwide, I don't think those can be produced efficiently in massive quantities in urban systems. So you need land for this, and these are the primary calorie sources for the world food system. So I encourage people to do these things. It's fine, but we need to look at them as one specific component of the entire food system. There is, of course, a little bit of concern sometimes if you do this in cities with high degrees of air pollution. What you're then eating on your vegetable may not always be as healthy as you think, but hopefully that's not the case.
Yeah, I would add that soil contamination is also a similar issue in some highly industrialized cities that have experienced some land use change. But I would also add, I really appreciate both of your points. I know in the US, at least, there's been preliminary evidence that community or home gardens can improve the nutritional quality, especially in low-income neighborhoods, even if they're not necessarily meeting a family's entire dietary needs. And I also really appreciate your point about reconnecting people to where their food comes from. There was recently a survey of adults in the United States, and 7% of people thought that chocolate milk came from brown cows, whereas regular milk came from white cows, which is not the case, in case anybody out there was confused.
Who knows? Maybe it's true.
So I agree. I like the concept of sort of reconnecting people to the land and the farming system that is feeding them. Moving on to another question from our audience. We have a question coming from South Asia talking about millets, which are historically a grain that was a big part of the diet. And she's asking about what can consumers do to try to push for policy change to promote them as a staple crop. I would expand it beyond South Asia to say that lentils, which are definitely a staple in South Asia, offer a lot of solutions for sort of other areas that are perhaps over-reliant on maize or wheat. So sort of that as a broader question.
Yeah, no, I completely agree. We have probably become a bit over-reliant on too few crops to provide the bulk of our nutritional supply in terms of calories, but also some other things such as proteins. So I think there is a huge need to spend more effort on alternative crops that could also provide more interesting solutions to diversify cropping systems and crop rotations. And it's not only a problem in developing countries. I would actually also argue even in places like here in Europe. So what we have seen in recent years here, largely driven by macroeconomic drivers and subsidies, a complete disappearance of proper crop rotations. So in the UK, it's wheat, and oilseed rape and whatever. Too few crops. So you have a similar tendency in some other parts of the world. So if we can find ways to improve crops such as millet, but also many of the pulses, grain crops, and pulses that are really a big supply also then for protein, particularly in South Asia, and particularly in India. India is the largest producer, consumer, and also importer of pulses. So lentil, chickpea, cowpea, whatever they are, there's still huge amount of work to be done to improve those in terms of their productivity, in terms of their nutritional value, their resistance to diseases and insects. So I wouldn't call them neglected crops because many of them have received attention also in research, but the advances in those crops have probably been a bit insufficient, and there's a lot to be done and possible to increase their yields and therefore also make it more attractive for farmers to grow them, and then make them also more affordable for, if you had higher production of it, more affordable for consumers to make them part of their diet. So I think it would be great to do more work in this area, and I'm personally very keen on that too.
Great. Well, we're starting to run out of time, so I'm going to encourage anyone that has any last-minute burning questions to try to tweet them in. At the moment, I have just a couple questions sort of on next steps and what people can do. The first one is a question about the role of the private sector in sort of bringing about the transformations of the agriculture sector that we've been talking about this hour. So if you could start that, and then I have another sort of related question after.
Okay. I've never worked in a private company, so but I need to make this as a statement right away. So, but I've worked with many private companies over the years on many issues. So even though we sometimes disagree in terms of the appropriate solutions for farmers or consumers, I would say by and large there is a lot of common interest, and to me, the private sector is an extremely important part of the solutions that we need. There is sometimes, of course, a concern that driven by profit and the demands of shareholders and so on, there may be a temptation to market and sell things that are not as good for the environment or other types of things that we're interested in than we would like it to be. But I think increasingly that is also not necessarily part of the vision and mission of many companies, particularly major multinational companies that I interact with. I think some of that stigma is a bit more of that label that they're often being given as sort of commercializing things that then lead to negative impacts on farmers or health or the environment. I think that is something that may have happened in the past, but I don't think this is that significant anymore today. Personally, I don't believe that. So the key issue for me is that we need to find effective ways in aligning the investments and activities of public and private sector, and particularly also finding better ways of more open intellectual property management. I'm very concerned about the issue of people, even in the public sector, increasingly wanting to protect many things, and at the same time, then a lot of good ideas and innovations not reaching farmers more quickly because of these types of approaches. So I think if we can move to a more open innovation system in which public and private sector would be willing to work more together and also share their knowledge, their ideas, their IP more widely, we would make a lot more progress. I know that is not easy, but I think if we want to tackle the big things in agriculture, we'll have to move away from some of the constraints of the past and to find new ways of more effective public-private partnership, though that's really then a benefit for both sides. But to me, for also implementing the SDGs, businesses, and I include them as farmers because farmers to me are businesses, are going to be major drivers.
Yeah, I think too, it's worth noting that IRRI, the International Rice Research Institute, has a really good example of how public-private partnerships can work. Achim, was it for golden rice or was it a different, the
Well, there are different ones. I mean, the golden rice is a very specific example because some of the initial development in IP took place in the private sector, in that case in Syngenta, but then was given to the public sector, in that case IRRI, under a humanitarian license, so that it can be freely used for in development of golden rice with vitamin A enrichment in the developing countries. So that's an interesting example. So where I think a company has realized, okay, if we don't use it for ourselves, maybe it can have much better potential for public sector use. It'd be good to see some more examples of this kind, that kind of proactive behavior. But there are other mechanisms that people use to collaborate more, and also in often or sometimes multilateral consortia in which actually many companies participate with one or more public sector organizations. And then you basically have mechanisms that apply to everyone the same way. And so the more open access to germplasm, to IP, to whatever knowledge. I'd like to see more of those in general.
Yeah, so difficult to do, but there are some first steps and some first successful examples that we could build on. The last question that I think I'll end on is, what can consumers do to impact this sector? So, when I go to the grocery store tomorrow, what should I do? When I go to the farmer's market, when I call my congressperson, what should I say? Sort of, what are all of the ways that I can be empowered as a knowledgeable consumer to bring about change?
Well, I could give you a long lecture of what would be, the most healthiest and environmentally friendly menu that you should be putting together for your daily consumption. But realistically speaking, there are differences in culture that drive the choices, and there are differences also in what people know about these things. So, to me, everybody has to make a conscious choice of what you want to eat. So I grew up in a family in Germany where meat was part of the staple diet. We're meat eaters, so it was just normal. So for me, in my particular case, the main question is, all right, it's not about whether I eat meat or not. I like eating meat. It's more of a question of how much do I eat of it and what kind. And how often, so I can make adjustments of that kind, and then also make similar adjustments in other parts of my diet that sort of eliminate things that I know aren't necessarily that great for me anyway, so not that healthy, or might have a somewhat higher environmental footprint than other things. So that's basically what everybody can do. So make a bit more educated choices. You don't need to go to the extremes. Not everybody has to become a vegan. Those who you want to be a vegan, that's fine. But there are lots of other things we can do. And then the other thing is wasting less. So again, there's a lot of it educational behavior. The family that I grew up with, the rule was pretty simple. You finish your plate. You don't leave things on your plate and throw them away. It was very, very uncommon in those days. And I've sort of kept this habit. So waste less, and then we also need to produce less. So quite a few simple things that everybody can do without having to be told by others what to do, basically.
That's great. I especially appreciate the point on food waste. Again, most familiar with the United States, but we throw away an obscene amount of food. So definitely lots of room for improvement there. Achim, relating to this final question, if you wanted to do a little bit more and potentially pursue a career in this area, or become a practitioner, do you have any sort of different advice that you would offer for people like that?
It's difficult because I'm totally passionate about agriculture and agricultural science in particular, and I think it's really good. anyone who in particular is interested in science, it is not boring at all, in the sense that you have plenty of scientific challenges to work on that actually are important. They're not sort of made up in the mind of to figure out, okay, what am I going to do next? No, they are really big things. They have a clear applied focus, and within that context, one can do nowadays really, really high quality in modern science, even of a very basic kind. So it's an exciting profession to be in, actually. And it's in some ways the same for farming. It's much more than it used to be, and so I think the only advice I can give to people is, if you're not in it already, check it out, and and see what the fun thing is that might work for you in any place in the world. And it's really, really an interesting profession, and there are many entry points to that career.
Well, that's fantastic. And on that note, I would say if you're slightly interested, but not sure if you want to pursue a long-term career on this, and if you enjoyed Professor Dobermann's speech, our Ag MOOC Feeding a Hungry Planet is going to be launching again in spring of 2018, or there are lots of other courses on the SDG Academy that you could check out on other issues around sustainable development. Achim, I'd like to thank you so much for taking the time today to speak to our live audience, and thank you also for your broader leadership on food security, sustainable agriculture, and wishing you and everybody who's been watching a great rest of your day.
Thank you. I hope this worked out. The technology was a bit of a challenge, but
yes, apologies for our late start, everyone.
Good. Goodbye, everyone.
Bye.